In this video we're going to think about the strange case of delta G equals 0. We're going to think about what happens to a reaction when delta G is equal to 0. So here's our example. We're actually going to look at water boiling in this case, turning from a liquid, so water, into steam, water vapour. And at 373.15 Kelvin, or we might think about that as 100 degrees centigrade, we'd find here that delta G is equal to 0 for this reaction. Now, is the reaction feasible or not at this temperature? The condition for feasibility is that delta G must be strictly less than 0. We can probably understand why delta G bigger than 0 would give an unfeasible reaction, but what about delta G actually equal to 0? Now, if delta G is equal to 0, then one other way of writing delta G is to think of delta G as equal to the free energy of the products minus the free energy of the reactants. And with that definition, what we can see is if this is equal to 0, then what we're basically saying is that G of the products is equal to the free energy of the reactants. So we're in a situation here where the free energy of reactants and products are equal, so neither of the two is more stable. So which will form? Will it be liquid or gas? Now, probably you've grown up thinking, well, 100 degrees C is the boiling point of water, and at that point, all the liquid water will turn into gaseous water. Now that will be the case in an open system, but in a closed system where an equilibrium can be established, something quite different happens. And this you can work out from this very famous relationship here. Delta G is equal to minus RT times ln Kc. So just to define our terms, this is the gas constant, 8.314 joules per Kelvin per mole. This is the absolute temperature in Kelvin. Kc is the equilibrium constant according to concentrations. So for this reaction, if we were to do it, it would be the concentration of water in the gas phase over the concentration of water in the liquid phase. And you can rearrange this very famous relationship and turn it into this one, which says that Kc is equal to e to the minus delta G over RT. Now, if delta G is equal to 0, then we can solve for Kc, and we find that e to the power minus 0 is just going to be 1. So we've got Kc equals 1. And what that basically means is that the concentration of H2O gas must be equal to the concentration of H2O in the liquid phase. So if we had this in a sealed container such that we could reach equilibrium and we put it at exactly 100 degrees C, we would expect to see a 50% of the molecules will be in the gas phase and 50% of the molecules in the liquid phase, or the equal concentrations in the gas, sorry, not 50% of the molecules necessarily, but an equal concentration in the gas phase as in the liquid phase. So what does it actually mean then if delta G is equal to 0? Well, fundamentally what it means is that we have an equilibrium established between reactants and products. Equilibrium will always be established if it's a closed system. We'll have Kc equals 1. Now